Greetings, mathematicians. Yesterday you worked on adding and subtracting fractions where you had to change the denominator for both fractions. Today what we're going to do is our learning target is I can estimate and accurately subtract a proper fraction from a whole number. So we're going to be looking at whole number answers and figuring out how to solve those subtraction problems. So our first problem says Ashley made 1 cup of kimchi soup for lunch. She ate 3/4 of it. How much is left in her thermos? So remember, when I'm looking at a word problem, the first thing I have to do is underline my important numbers. So we've got 1 cup and 3/4. Also, it says how much is left in her thermos. Whenever I say that word left, that helps me to see that I'm working with a subtraction problem. So I'm taking 1 minus 3/4. Now, we know from yesterday that we need to make sure that whenever we're subtracting with fractions that we have a common denominator, which means, remember, every time I have a whole number, that's really like we're saying we have the same numerator and denominator. Since our denominator this time is fourths, I know that 4/4 is the same as 1. So now my problem just becomes 4/4 minus 3/4. So when we're subtracting, remember our denominator stays the same. So we have fourths still. 4 minus 3 would be 1. So she should have 1/4 left in her thermos. We can visualize this problem if we start with 1 over here, and she ate 3/4. When we look at the difference between these two, we see that there's just a small part here that's the difference, right? We see, and that's about 1/4 because the 3/4 and the 1/4. We can also estimate and say, well, 1 cup, of course, is 1 cup. 3/4 is a little bit, or is between 1 and 2, so my answer should be smaller than 1, but greater than a half, and it is, smaller than 1, but not greater than a half, less than a half, and it is, because 1/4 is our answer. All right, let's take a look at another one. This one says, Keon ordered a pizza for dinner. It was cut into 10 pieces. He ate 6 slices. What fraction of the whole pizza is left after he eats? So this one is a little bit different. We've got 10 pieces, and they ate 6 slices. And for our answer, it says what fraction of the whole pizza is left after he eats. Remember, if I see left, that helps me to see that it's a subtraction problem. So for this one, it's not made into fractions already. I just have to think, if I have a pizza that's cut into 10 pieces, that's like I have 10 tenths. Right? So it has 10 pieces, 10 tenths is what we start with. That's our whole. If we ate 6 out of 10 pieces, remember that would be 6 tenths. So 6 out of the 10 pieces, we can make that into a fraction. And now we can subtract because we have the same denominators. 10 and 10, remember our denominator can stay the same. 10 minus 6 is 4. Now, can I simplify? Yes, I can, because if I look here, these are both even numbers, so I know that I can simplify. If I were to think of my factors for 4, remember that's 1, 2, and 4. If I think of my factors for 10, that's 1, 10, 2, and 5. I heard a 2 in both of those, so I could divide both my numerator and my denominator by 2. And we can simplify it so that our answer, 4 divided by 2 is 2. 10 divided by 2 is 5. So there's 2/5 left of the pizza. Again, we can visualize this if we started with 1 whole and we ate 6 slices. 6 tenths is slightly bigger than a half, so I'm going to go to right about here. If we look at the difference between 1 and 6 tenths here, so if I were to extend this up and we're looking at this section right here, that's slightly more than a quarter, but not as much as a half, so this answer does make sense. Oops, I accidentally drew a little extra line there. If we were to estimate, we start with 1, and 6 slices again was a little bit more than a half. So if we take 1 minus a little bit more than a half, we should be left with a little bit less than a half. All right, this one says Lucy made 6/8 of her free throws. What fraction did she miss? So our important numbers again, we've got 6/8, and it says what fraction did she miss? So if we think about her total number of free throws and the amount that she made, remember we're subtracting. Now, we only know that 6/8 is what she made. if we want to figure out how much she missed, we have to think about what are her total number of free throws that she had, and then take away the ones that she made. So if I'm dealing with eighths, if I want to make eighths into a whole number, I have 8 eighths. So we have 8 eighths minus 6 eighths. Our denominators are the same, so I can keep my denominator the same over here. Now I have 8 minus 6 would be 2. So I have 2 eighths of the free throws that she missed. Now, can I simplify this? Yes, I can, because if I think of my factors for both 2 and 8, they have a greatest common factor of 2. So I can divide both my numerator and denominator by 2. And that gets me 2 divided by 2 is 1. 8 divided by 2 is 4. So we have 1/4 for our answer here. Again, if we wanted to visualize it, we could. We're started with 8 eighths. If we subtract 6 eighths from it, we know that 6 eighths is a little bit more than a half. And so we should have a little bit less than, we should have about a quarter difference between our 1 and our 6 eighths. Same thing with our estimating. If we have a 1 and we're taking away a little bit more than a half, we should be left with a little bit less than a half as our answer. All right, this one says Logan was on his computer for 2 hours. He coded for 1/3 of an hour. He played Minecraft for the rest of the time. How long did he play Minecraft? Now this one's a little bit different because it says he was on his computer for 2 hours and he coded for 1/3 of an hour. Not 1/3 of the 2 hours, 1/3 of an hour. So we have to be careful here. Our whole number can't just be 2 over 2, right? Because if we did that, then we wouldn't have a common denominator. So what I need to do is think about how, if I have 2 full hours and it's split into thirds, how many 1/3 pieces is that? So if I have 1, 2, 3, 4, 5, 6, 2 hours is the same as 6 thirds. So I'm going to take 6 thirds minus the 1/3, because 6 thirds represents the 2 full hours that he played, minus the 1/3, and we're left with 5 thirds. Now if I look at this, remember, I want my answer to be either a proper fraction or a mixed number. Since this fraction is improper, the numerator is greater than the denominator, I need to make this answer into a mixed number. So 5 thirds, remember I think about how many 3's can go into 5, that goes in there once. 5 minus 3, we're left with 2. Remember, my quotient is my whole number, my remainder is my numerator, and my denominator stays the same. So 1 and 2/3 hours is how long he played Minecraft. This one says, Mrs. Carlson made 3 pies. Her family ate 8/12 of a pie for dessert last night. How much pie is remaining for the rest of the week? So again, here we've got 3 wholes, and it is split into 12ths, because we have 8/12 here. And we want to say how much pie is remaining, so we're subtracting here. Now, remember, I have 3 full 12ths, so it's like I have 3 groups of 1/12. So I need to make my 3 into 12ths. Now, how can I do that? I can say, well, it's like I have 3 1/12 pieces, or 3 full pies of 1/12. So I could draw a pie with 12 pieces in it. So it'd be 12, 12, and 12. When I put all these together, 12 plus 12 is 24, plus another 12 is 36. So 3 whole pies is the same as 36/12. So now I've got 36/12 minus 8/12. My denominator can stay the same. We're dealing with 12ths. And if I take 36 minus 8, I get 28. So we've got 28 twelfths. My numerator is bigger than my denominator, so I need to reduce or make this into a mixed number. So if I looked at 28 divided by 12, I know that 12 goes into 28 two times. 2 times 12 is 24. 28 minus 24, we're left with a 4. Remember, my whole number, my quotient is my whole number, so I have 2. My numerator is my remainder, 4. My denominator stays the same. So I have 2 and 4 twelfths. Now, I can reduce this even further because 4 twelfths is not the smallest possible fraction. So my 2 is going to stay the same because my whole number is not going to be changed. But I can divide, if I think of my factors for 4 and 12, well, 4 has 1, 2, and 4. 12 has 1, 12, 2, 6, 3, and 4. So I can divide both of these by 4. And I get 1/3. So there's 2 and 1/3 pies remaining. So remember, if you get an answer that is an improper fraction, you want to make sure you turn it into a mixed number and reduce it to simplest form. So your learning target for today was I can estimate and accurately subtract a proper fraction from a whole number. So making sure that whenever we have a whole number, we can make it into, if it's a 1, we can make it into the same numerator over the same denominator. And if it's greater than 1, then we have to change it to say how many, so if it's, for example, 2 full wholes of something, and we're looking at twelfths, we want to say, well, how many twelfths would be 2 full pies? So it would be 24 twelfths. Go ahead and try your Go Formative for today. And if you have questions, make sure you're asking me tomorrow.